This is a question of energy stores and work. So in part A, as the swimmer pushes off the side, the energy in the chemical potential store of the swimmer is transferred to energy in the kinetic store of the swimmer through the action of force, which is the pushing force, and this is via the mechanical pathway. So take note, when you describe energy store, always tag the type of energy to the object where you can find the energy store in. Now in part B, describe how the swimmer does so on the water. So again, the swimmer does so on the water by pushing against the water. So there's a pushing force on the water itself, and therefore the water will move in the direction of this force. And this is how the swimmer does work on the water. Now we can extend this question, and you can think of how Newton's third law applies on the swimmer. So when the swimmer pushes back on the water exerts an equal and opposite force on the swimmer in a forward direction, and this is Newton's third law at play. And therefore this is why when you kick the water back when you're swimming, the water actually pushes you forward, making you swim forward. And part 2, state what eventually happens to the work done by the swimmer on the water. So we were saying just now in part 1 that the water moves in the direction of the kick, of the push, and therefore there is some kinetic energy in the water. This kinetic energy in the water is transferred into internal energy of the water. Therefore, as you kick the water, you actually increase the temperature of the water by a little bit.